Hi, it's Mr. Adams from Midwood High School, and this is a video on writing and naming ternary ionic compounds. As we discussed before, ternary simply means that the ionic compound has three or more different elements in it. Okay, and we know from experience that ionic compounds are comprised of positive and negative ions together. Once you are able to realize that you have a ternary compound, please don't forget table E, okay? Because on table E, it has the polyatomic ions listed there for you, and it also has their names. And as a reminder, anything ending in ate or ite, okay, will definitely be on table E in terms of being a polyatomic ion. We will use the crisscross method just like we use to do for binary compounds, binary ionic compounds, okay? But one more thing we have to look out for is that if the eventual subscript that we're going to put down for the crisscross, if it's 2 or higher, we will use parentheses. Now, once again, if this sounds a bit confusing, not a problem. We'll do some examples. Okay, now let's say we have these pairs of ions, right? And we have, and notice in each example, we have polyatomic ions. We will simply use the crisscross method, okay, to get the final formula. Now, Na plus, right, is the same thing as Na plus 1. Now, this one will go towards the CrO4 on this side in the subscript, and this 2, okay, will go towards this side over here of the Na. All right, so what's going to happen, we will get Na2CrO4 as our final answer. Now, we don't have to show the 1 that went down to the CrO4, and we're done. We don't have to use parentheses because, once again, the rule is for 2 or higher going down to the subscript. So Na2CrO4 is our final answer there. Okay, so moving on. Now, we have here NH4 plus, right? Now, NH4 plus is ammonium, okay, and PO4 is also on our table E. So we have 2 polyatomic ions here. Now, as before, same thing. The 1 goes over to the subscript over here, and since it's the 1, we don't have to show it. And this 3 will go to the subscript over here. Now, very, very, very important, guys. We do not change anything about the polyatomic ion. The best thing we do is put parentheses around it, and that's it. But if NH4 is to start out with, that's the way it's going to end up. If it's PO4 to start out with, that's the way it ends up. We don't change anything about it. So the final answer over here would simply be, okay, let me get a different color. NH4 parentheses 3. Now, why parentheses 3? This number coming down is 3 coming down right here. Coming over here is 2 or higher. So we put a parentheses around the polyatomic ion. And on this side, it's PO4. And you're done. So NH3, okay, NH4, 3, okay, parentheses, and PO4. That's your answer there. And for this one over here, the last one, okay, we have Ba2 plus. Okay, that 2 goes over here. And we have S2O3. This is polyatomic ion. And this 2 will go over here. Okay? Now, what from experience, right? The 2's that go on each side are able to cancel each other out. So the final answer will simply be BaS2O3. Okay? And that's our ternary ionic compound. So we have 1, 2, 3 ternary ionic formulas from the crisscross method. Okay, we have some other examples here, so you can pause the video really quick and see how we do with them. Okay, these 3 guys, we have Mg2 plus here. The 2 will go over here. Now, notice once again, the 2 goes to the subscript over here. It does nothing to the NO2. The NO2 is a polyatomic ion. It stays that way. Do not change anything about it. Don't change the M. Don't change the O. Don't change the 2. Okay? Now, NO2 minus, that means 1 right here. and this one goes over here to the Mg, right? So that will simply be Mg parentheses NO2 parentheses 2. Okay? Now, that's that answer. And this guy, the second one with Al and PO4, right? The 3's are able to cancel each other out, so you'll just simply get AlPO4 as your final answer when you do the crisscross. Okay? And the last one, okay, this is Li plus 1, alright, and that one goes over here. And this 2, okay, goes to the other side, right here. So you'll simply get Li2 CrO4 as your final answer. Okay, alrighty. Now, in terms of naming these guys, right, there's a simple way to name them. The simple rules you're going to follow. The positive ion always stays as is. The guy in the front, positive ion for the ionic compound, stays as is. Okay, any polyatomic part keeps its name, and any negative monoatomic part gets an IDE ending. So we'll go look at the examples, and we'll name them, and we'll call it a day. All right, so this guy right here, if you had to name it, right, the first thing you do is realize that it's ternary, right? So we have Na, we have Cr, and we have O, so we know it's ternary. So what you do, you look on your table E, right? So let me expand this a bit. This table E right here, and you see that you find which part of it's polyatomic, and you see there's a CR. I'm going to scroll this down a bit. Let me see. CrO4. Let me scroll this down. See over there. CrO4 chromate. Okay, you use that. All right. So CrO4 is chromate. So all you simply do, the Na stays the same. You don't change anything about its name. Okay, so Na stays Na. So you simply say sodium, okay, and chromate. So notice that polyatomic ion parts, nothing changes about the name. On table E it's chromate, and in this final name it's chromate. And the positive ion, okay, Na metal ion, positive ion also keeps its name. So it's very simple, sodium chromate. This guy right here, and the rule once again says any polyatomic ion part keeps its name. This part's polyatomic, and also this part's polyatomic. So this name will simply be ammonium, okay, phosphate. You're done. Notice that both polyatomic parts keep their name. There was no modification. All right. So we have ammonium phosphate there, and we have sodium chromate there. And this guy, BaS2O3, right? Remember, there's 3 or more different elements, ternary. So you look on your reference tables, look on table E, you see the S2O3 part, right, is called, let me see, thiosulfate. Okay, so this will simply be barium, okay, because the positive ion does not change its name. Barium thiosulfate. And you're done. Okay, so that's 3 guys we named right there. Alright, and how do we name these guys right here? I want you to name them. So pause the video really quick and do those. Okay, so we know from experience, right? We have 1, 2, 3 things. You look on your reference table, you'll find that NO2 is your polyatomic ion, and NO2 minus would be nitrite. We know from experience Mg is magnesium, so you just put down magnesium nitrite. Alright? And you're done. Al is aluminum, so you put aluminum down. And PO4 is on your periodic table is phosphate, so you put phosphate down. Once again, polyatomic ions, you don't have to modify their names. Okay? And this last guy right here is LiCrO4. The Li will be lithium. And the CrO4 will be chromate. And you're done. Okay, guys. As always, hard work plus sacrifice equals success. I did a combination of writing and naming polyatomic ion formulas for ionic compounds. It's very simple. Remember, use table E, follow the rules, and you'll be okay. Take care.